Hello everyone, my name is Rama and I'll be working with my group mates Lexi and Jacob, and today we will be talking about Point Pleasant Park, known as Amatukari by the Mi'kmaq Nation. This park is an important urban forest in Halifax that went through a major ecological reset after Hurricane Juan hit on September 29, 2003. The Category 2 hurricane destroyed over 70% of the park's forest canopy, completely changing the landscape and starting a new phase of forest recovery known as secondary succession, by referring to Pearlie and others 2008. Before the storm, the park was mostly an even-aged Acadian forest, which made it especially vulnerable to strong winds. Research done 2 years after the hurricane showed that native tree species like red maple and paper birch were already coming back naturally, dominating the seed bank and seedling layers, also by referring to Pearlie and others 2008. The study also found that the cleanup efforts did not seriously harm the soil and that invasive species were not a major issue inside the park. This suggested that the forest had a strong chance to recover on its own. Our presentation builds on this earlier work by looking at 20 years of monitoring data. We are examining how the forest has changed over time, focusing on its structure, main tree species, and biodiversity. Based on the early sign of natural regeneration, we expect the forest to keep moving toward a mature Acadian forest, although being an isolated urban park might affect how quickly and in what way it recovers. Our project was guided by three key objectives. Lexi will cover the first objective on the overall community changes, and Jacob will discuss the third objective on biodiversity metrics. For my section, I focused on the second objective, which is to track the population changes of the initial dominant species, which is red spruce, and the current dominant species, which is red maple.
Hi, I'm Lexi. I'll be talking about the methods starting with the area of study. So there were 6 designated study areas in Point Pleasant Park, Nova Scotia, Canada. Each area was identified as a separate site, sites 1 through 6, as seen in Figure 1, to monitor the change across the entire park. Now onto the data collection portion of the methods. Plant diversity was measured by first dividing the site into 4 quadrants. In each quadrant, a pen was randomly tossed to determine an unbiased sampling point. A quadrat was placed so the pen was at its center, and the vegetation inside the quadrat was assessed visually. Percent cover for needles, leaves, woods, and plants was estimated based on observational judgment. This was repeated 3 times for each quadrant. Tree diameter was measured by using a flexible measuring tape wrapped around each tree at breast height, approximately 1.3 meters above the ground. These trees were identified and counted as well. Together, these measurements provide the data needed to calculate 6 variables used to assess ecological trends over time. Now on to the last portion of the methods, the statistical analyses. Using the data collected, 7 variables were calculated: total density, average diameter at breast height, species richness, Shannon's diversity, Pylo's evenness, red spruce abundance, and red maple abundance. Once each variable was determined, it was compared with historical data from previous studies conducted at the same site. Linear regression analyses were performed to examine long-term trends and evaluate how the forest community has changed over time. For each variable, the p-value and the coefficient determinant, r squared, were calculated. A p-value less than 0.05 was considered statistically significant. On to the results of the study. Linear regression analyses were conducted for all the variables, as seen in Table 1. Total density showed a significant positive change over the years with an r-squared value of 0.45 and a p-value of 3.9 times 10 to the negative 13. DBH showed a significant negative change with an r-squared value of 0.15 and a p-value of 0.0002. Species richness had the highest coefficient of determination, so the r-squared value among variables, and the r-squared value was 0.58, with a p-value of 2.6 times 10 to the negative 18. Pylo's evenness didn't show any statistical significant results with an r-squared value of 0.04 and a p-value of 0.08. Red spruce abundance showed a significant positive change with an r-squared value of 0.13 and a p-value of 0.0004, as did the maple abundance, which was an r-squared value of 0.14 and a p-value of 0.0003.
Hello. In the next parts of this presentation, we will be discussing three major questions. The first is, how has the overall forest community changed over time and why? What can you predict will happen to the overall community as the forest moves towards climax community and why? That will be answered by Lexi. The next question is, how has the density of the dominant species in 2004 as well as the dominant species in 2024 changed over time? That will be answered by Rama. And the third and final question, answered by me, will be, how has the chosen community metric changed over time and why? What can you predict will happen to the chosen metric as the forest moves towards its climax community and why?
Question 1 will be talking about the overall change in forest community. If we look at Figure 1b, it shows that the average DBH has decreased over time. The regression line has a negative slope, meaning in more recent years, trees have generally gotten smaller. This is likely because Hurricane Juan removed many of the large mature trees in 2003, and now there are just thinner, younger trees. If we look at Figure 1c, shows that Shannon diversity has increased over time. The positive slope indicates that the forest now contains a greater variety of species and even more distribution among them. This increase in diversity is likely due to the openings created by the hurricane. Now adding on to the last slide, if we look at Figure 1d, it shows a strong increase in total density over the years. The positive slope indicates that the forest is becoming denser. The canopy was opened in 2003. Growing conditions improved for new seedlings because of increased sunlight and reduced competition. Figure 1e shows that species richness has increased. This is likely because the hurricane created a mix of habitats. Some areas were fully open, some were partially damaged, and some were still sheltered. All these conditions support a wider variety of species. All the data collected are consistent with a very similar study that examines the succession at Point Pleasant Park, Halifax, Canada, after Hurricane Juan over the years between 2006 and 2016, which found all these variables increased except DBH, which is Turchin 2016. Now for predictions for the overall community as the forest moves towards a climax community. As the forest continues to develop and move towards a climax community, we can predict that species composition and structure will gradually stabilize. Competition for light, space, nutrients will intensify, leading to self thinning and an increase in average tree size as mature, shade tolerant species dominate. Consequently, species richness and diversity may plateau or slightly decrease, reflecting the transition from early to late successional stages dominated by long lived species such as red spruce or red maple.
Thank you, Lexi. So, I will now present our findings on the dominant species. Let's start with red maple in figure 2a. Our analysis shows a strong positive linear trend. The steep slope indicates a rapid population increase over time. This strongly supports our hypothesis that a fast-growing shade-intolerant pine or species will rapidly colonize the open, high light condition created by the hurricane. In fact, research conducted in this very park just 2 years after the storm confirmed that native early succession species like red maple were already dominating the seedling layers by referring to Pearly and others 2008. Now let's look at the red spruce in 2P. In stark contrast, we see only a weak positive trend indicating a very slow and stable population increase. This perfectly fits its profile as a shade-tolerant climax species. Long-term study of forest dynamics showed that such a species often gradually increase in the understory after disturbance rather than dominating immediately, as their strategy is to persist and slowly recruit over time by referring to Herman and Popset 2019. And quality control statement. I have reviewed the data collection and statistical analysis for these graphs and confirmed that they are presented accurately. Opposing trends are a very good example of secondary succession. The hurricane created a blank slate with abundant light, which was a perfect opportunity for the fast growing pioneer like red maple to explode in numbers, exactly as the early research by Purley and others 2008 documented. However, the very act of this growth changes the forest. As the red maple grows, they create a shaded canopy. This new environment becomes difficult for shade intolerant red maple seedling to survive in. This leads us to a key prediction for the climax community, as we predict that the red maple population will eventually stagnate and then decline. Meanwhile, the patient shade tolerant red spruce is perfectly pre adapted for this future. As seen in other long term studies, climax species like this are positioned to steadily increase and ultimately ascend to become the dominant canopy species of the mature Acadian forest by referring to Harmon and Pabst 2019. This illustrates the dynamic yet predictable nature of forest recovery.
Hello. In this slide here, we can see the Pilao Evenness Index, or J value. It spans the last 24 years, 2004 up until 2025, and it shows the hello. In this slide here, we can see the Pilao Evenness Index, or J value. It spans the last 24 years, 2004 up until 2025, and it shows the evenness at the different ecosites that have been studied. It includes a line of best fit on a negative trajectory and its coefficient of determination. All of these will come into play in the next slide. After reviewing the given data, we believe that the Pilau's evenness index will continue to fall until a climax community has been reached. When this happens, the J value, or the Pilau's evenness, will remain constant. We concluded this after reviewing figure A, which was seen on the previous slide, which shows a linear decrease in Pilau's evenness index. When reviewing the slope of the linear regression line, we further concluded this theory as it shows a slow negative trajectory. Why we believe this value will eventually plateau is due to how the climax community involves an equilibrium of species. As mentioned on a previous slide, the species richness has continued to increase in recent years, and as such, a single totally dominant species is unlikely. Dr. Kevin Keyes also supports this in his 2019 study, Forest Ecosystem Classification, in which he states that Point Pleasant Park would have a climax community where red spruce dominate the ecosites, while the number of white pines and eastern hemlocks would vary. As stated before, this is directly reflected in the data provided and follows the conclusion that we made that a single dominant species is unlikely, and the Pilau evenness will fall until a climax community has been reached. We would like to thank Dr. Zaguras for her assistance with the initial explanation of our assignments, and our TA, Jovia Gallant, for providing additional help with any questions. Finally, we would like to acknowledge the Mi'kmaq who have lived, grown, and protected this unceded land since time immemorial, and allow us to learn and grow in this institution of education.
So basically, our data tells one main story, which is the forest is super resilient and is following a pretty classic compact script. Let's break this down. So the forest is booming back to life. All our numbers on trees density, species variety, and overall diversity are way up. It's a proof that the forest is successfully rebuilding itself. Also, our predictions were right. So, just like we thought, fast growing red maple jam in first to take over the open space, but now we're seeing the slow and steady red spruce starting its climb, which is the first sign of the mature forest to come. In addition to that, you can see the recovery happening. The fact that the average tree is getting smaller sounds weird, but it actually makes sense because here are thousands of new young trees filling in the gaps. The forest is getting crowded and competitive, which is a normal part of the process. In the end, Hurricane 1 was not the end of the story. It was a dramatic new beginning. It wiped the slate clean and let us watch the forest rebuild from the ground up, following its natural blueprint. So, to wrap this up, the journey is not over. We expect things to keep changing with more competition and red spruce eventually becoming the dominant tree. But the last 20 years have given a sign that have given us a clear and hopeful message that Point Pleasant Park has an amazing built-in ability to heal itself. It's not just a park, it's a living lesson in how nature can recover, adapt, and thrive no matter what. Thank you for watching. See you soon.